Good morning, grade 12 learners. Good morning, teachers. I hope you must be familiar with me by now. My name is Mohapi, Mathematics Subject Advisor from Hotel District. So today I'm going to take you through some few concepts in Euclidean geometry and try to prepare you for this coming test that will be written next week, Monday. Today is the 10th. We all know that on the 17th of March, grade 12 learners will be sitting for a common test in the province. So I'm just going to take you through the possible questions in that test and see how to approach those questions. Thank you. As I've already alluded, one of the possible questions in this coming test will then be the proof of the theorems. Sometimes we as learners, we tend to ignore the proof. Remember, whenever you sit for a test or for examination, there is this section that we call the bookwork. Bookwork basically is where you prove the theorems or the rules. So for paper 2, we know bookwork takes 12 marks. So possibilities are some marks for bookworks will go for the proof of geometric theorems, those theorems in Euclidean geometry. So it is important for you as a learner to know the proof of those theorems. I cannot take you through all the theorems. I'll only take you to one of the theorems and then see from there. I'll try and do some applications. Thank you. Check. Let's go through this given diagram. In the diagram below, ABC is a tangent. You can see ABC, that line. ABC is a tangent. ABC is a tangent to the circle with center O at B. Prove the theorem that states angle DBC. We've got to prove that this angle DBC, let me mark it. We must prove that that angle DBC is equal to angle DEB. The two angles that I've marked, they must be equal. So that is what we are required to prove. The theorem states prove that angle DBC is equal to angle DEB. Thank you. Before we can start with the proof, let's start with the construction. Let's start with the construction. And in our construction, we draw diameter BF. Let me draw diameter BF. Here it is. It passes through the center. A diameter, that point is F. We draw diameter BF. We know that the line that passes through the center of the circle from this part of the chord to circumference to that other part of the circumference, that line is called the diameter. So a diameter divides the circle into two halves. So we have drawn diameter BF, and then let's join FE. FE. Here we join FE or EF. Thank you. Can I, just to try and simplify our workout, let me name this angle B1. Then here we've got angle B2, angle B3, angle B4. And then here let's name this angle E1, and this one will then be angle E2. Basically, remember the required to prove part. The question states prove the theorem that states DBC. Check DBC. Basically, DBC is our B, angle B1. We've got to prove that angle B1 is equal to, check DBC. DEB. Basically, it's angle E2. If I try and simplify the work for us, that is what we are required to prove. We've got to prove that angle B1 is equal to angle E2. Thank you. Let's prove now. Now here is the proof. If we look at the diagram, in our construction, we have said we have drawn diameter BF. Check BF is a diameter. So we know the theorem that states an angle subtended by diameter is equal to 90 degrees. An angle subtended by diameter is equal to 90 degrees. So you look here, you'll see that angle E1 plus angle E2 gives us 90 degrees because it's an angle subtended by diameter. Angle E1 plus angle E2, they give us 90 degrees. The reason for that statement is that That is an angle subtended by diameter. It's an angle subtended by diameter because we have drawn BF as a diameter. So BF subtends angle E, which is E1 and E2. So check again, O is the center. So we move from O, ABC is a tangent to the circle at B. So we say angle B1 plus B2 is equal to 90 degrees. Angle B1 plus angle B2 is equals to 90 degrees. Let's check the reason for that statement. Why? Can you give me the reason? Check out the reason, learners. Why do I say angle B1 plus B2 is equal to 90? The reason is because tangent is always perpendicular to the radius. You know the theorem that states a tangent to the circle is perpendicular to the radius at the point of contact. So that's why we say angle B1 plus B2 is equal to 90 degrees. Therefore, allow me to make B1 the subject of the formula. From here, you can see that angle B1 will then be equals to 90 degrees minus B2. 90 degrees minus B2. From this statement, B1, angle B1 plus angle B2 is equal to 90. We make B1 the subject of the formula. Then B1, if we make B1 the subject of the formula, B1 will be equal to 90 degrees minus B2. From this very first statement, angle E1 plus angle E2 is 90. Let's make E1 the subject of the formula. If we make E1 the subject of the formula from here, check. It therefore means angle E1 is equals to 90 degrees minus E2. Maybe I should clarify something first. E1 is equals to 90 degrees minus E2. But check B2 and E2. What relationship exists between the two angles? Check angle B2, it is subtended by arc FD. Check E2, it is also subtended by arc FD. What is the relationship between the two? Thank you. Some of you are getting it right. You can see it's angle B2 is equals to angle E2. Why? Those are the angles subtended by arc FD. Those are the angles subtended by arc FD. Check arc FD. FD subtends B2, FD subtends E2. Remember, what do you want to prove? You want to prove that angle B1 is equal to angle E1. Angle B1 is equal to angle E1. That is what you want to prove. You want to prove that angle B1 is equal to angle E1. Then, if B2 is equal to E2, I can substitute here. Instead of B1, I can say angle B1 is therefore equal to 90 degrees minus, I can substitute B2 by E2 because B2 is equal to E2. So B1 is equal to 90 degrees minus B2. Now I substitute B2 by E2. I substitute E2 by B2. Thank you. B1 is equal to 90 degrees minus B2. Check this statement. Let me say equation number 1. Check this one. Check the two equations. Remember, in that equation, if I have to write it down again, I said from here, if I have to write it down again, I say E1 is equals to 90 degrees minus E2. You can see B1 is equals to 90 degrees minus E2. E1 is equals to 90 degrees minus E2. Therefore, we can therefore conclude by saying angle B1 is equals to angle E1. Therefore, angle B1 is equals to angle E1 because they are both equals to 90 degrees minus B2. Both equals to 90 degrees minus E2. And that proves the theorem. That proves the theorem because remember, we wanted to prove that angle B1 is equals to E1. B1 basically is angle DBC. DEB is basically angle E1. So, in our workout, ultimately, we find that E1 is equal to 90 degrees minus E2, B1 is equal to 90 degrees minus E2. Therefore, it means B1 is equal to E1, both equal to 90 degrees minus E2. That is just an example of a possible question in this coming test for that will be written on the 17th, the next week, Monday. It's one of the possible questions. We must know the proof of the theorems. Remember how the diagram looked like? We had to construct, place, learners practice the proof of the theorems, because proving of theorems is one of the possible questions that we can expect in this coming test, or even in June exam, September exam, even the final examination. It's one of the possible questions. So we need to be prepared to prove. We need to know how to prove the theorems. Thank you. I want to take you through. You remember the first theorem that we did? I believe it is the theorem that states the line joining the center of the circle to the midpoint of a chord is perpendicular to a chord. That is also a possible theorem that you can be expected to prove. So you as learners, place your practice. Teachers, take our learners through the proof of that theorem. Now I'm going to take you through some few exercises related to that first theorem. Thank you. Let's practice this one. Number 2. In the given diagram, let's check. AB is the chord of the circle. Where is AB? AB is the chord of a circle with center O. Here is O. O is the center. And is 24 centimeters long. Check. AB is 24 centimeters long. AB is a chord of the circle with center O and is 24 centimeters long. It means from A to B, that distance is 24 centimeters. C, here's the point C, is the midpoint of AB. Remember the converse. C is the midpoint of AB. If C is the midpoint, it means this side is equals to AC is equals to CB. Remember, the whole of AB is 24. So it means AC will then be 12 centimeters. So is CB. CB will also be 12 centimeters. The question then states CE is perpendicular to AB. It's marked, it's 90 degrees. Cast the circle at E. Here it is, cast the circle at E. Calculate the value of X if CE is 8 centimeters. CE, this CE line, CE, cut the circle at E, and this CE is equal to 8 centimeters. So the question is, calculate the value of X. Calculate the value of X. X is basically the distance from O to C. The distance from O to C is our X. The key here, when solving this one, the key is to know that when you've got a circle, the radii of the same circle are equal in length. What is a radius? A radius is the distance from the center to the circumference. So, the radii of the same circle are equal in length. Check. OE. OE is the radius. OE is the radius. And OE is equal to X plus 8. That is OE. Check OB. OB is also our radius. What is the length of OB? Because it's also in the radius. OB is also equals to X plus 8. OB is also equals to X plus 8. So OB here is X plus 8. Then it means we can just use Pythagoras theorem then. You've got BC 12. OB X plus 8. OC is X. And this angle here is 90 degrees. So we've got a right angled triangle. So if we've got a right angled triangle, we can use the Pythagoras theorem to solve X. According to Pythagoras theorem, the square of the radius, X plus 8 squared, is equal to the sum of squares of the other two sides, X squared plus 12 squared. You see, this is the hypotenuse because you've got a 90-degree angle there. So X plus 8 all squared is equal to X squared plus 12 squared. According to what? We are doing Euclidean geometry. Why do you write that statement? According to Pythagoras theorem. That is according to Pythagoras theorem. Thank you. Let's expand here. X squared plus 16x plus 64. Then will equals to x squared is square. 12 squared will then give you 144. 144. Then what do you need to do? You just have to solve for x. Transpose. We've got x squared here. You transpose it to the left. Then it will be this x squared minus that x squared is 0. X squared cancels off. So we are left with 16x. We've got 64 here. We've got 64. You transpose. Here is our equality sign. This 64 transpose to the right. Then we'll have 144 minus 64. Give me the answer. 144 minus 64. Therefore, the answer is 80. Get it? 144 minus 64. We end up with 80. So all we have to do is to solve for x. Now have to solve for x, and then you just divide by 16. Both sides, therefore x will then be equals to 80 divided by 16. You can just use the calculator to determine the answer there. Ultimately, this will be the value of x in terms of centimeters. Remember, our length here from the problem itself, our length are given in form of centimeters. The units that are used here is centimeters. CE is 8 centimeters. AB is 24 centimeters. So it means even our x here, it will be expressed in terms of centimeters. So that is the value of x. X was 8 over 60 in terms of centimeters. Clear? Thank you. Thank you. Thank you. That is how to apply the theorems. Every time in Euclidean geometry, we need to apply the theorems, and we need to provide reasons for our statement. Every statement must be accompanied by a reason. Are we all clear on this one? Thank you. Let me take you through the other one before I give you an exercise to do. Let me take you through the other one. Remember, the main objective for today's lesson, to prepare you for this coming test. The test will be written on the 17th of March. I want to prepare the grade 12 for this coming test. Thank you. Next one of the possible questions. Remember what I said earlier? I said, be aware. Check out for the proof of the theorems. That's why I showed you a proof of the Tancourt theorem. I showed you the proof of that theorem. I did not do all other theorems. I only showed you one. Then I said there is also a possibility that there can be a question relating to the theorem. The theorem line joining the center of the circle to the midpoint of a chord is perpendicular to the chord. There can be a question based on that one. But now let's check this one. This one is a bit more general because it includes many other theorems. And in this case, let's go through it. O is the center of the circle. MPT is a tangent. MPT is a tangent. O is the center of the circle. So our task is determined with reasons x, y, and z. So we need to apply our theorems here to solve this one. I'm telling you, definitely, it will be we can come across the proof of the theorem, followed by either the application of theorem 1, and then there must be calculations where we need to calculate before we can go to the questions that requires you to prove. Let's solve this one then. O is the center, that is key. MPT is a tangent. So if MPT is a tangent, the question states determine with reasons x, y, and z. There we go. Determine with reasons x, y, and z. From the theorem that we have just proven earlier on, check 64, check z. 64. Remember, MPT is a tangent. PB is a chord. Therefore, 64 is an angle between a tangent and a chord. And according to that theorem, to Tancourt theorem, the angle between a tangent and a chord is equal angle in the alternate segment. That's why we say z in this case. Z, if we have to solve, z is equals to 64 degrees. Determine with reasons. Now you've got to provide a reason. Why do I say 64 degrees equals to z? It's because of the Tancourt theorem. Tan-Cot theorem. That's how we determine Z. Now we've got the value of Z here. Remember, Z is now 64 degrees. Z is 64 degrees. It is always advisable to mark the angles that you have calculated. Indicate them on the diagram. Thank you. The next one. X is covered. Let's check at Y. Y. What is the relationship between Y and Z? Y is an angle at the center. Z is an angle on the circumference of the circle. So there is a theorem that states angle at the center is twice the angle at the circumference of the circle. So we say Y is equal to twice Z. Angle, the reason is angle at center is equal to 2 times the angle on the circle, on the circumference of the circle. So we just have to substitute Y is equal to 2. We have already calculated Z. Z is equal to 64. You substitute Z by 64 degrees. Therefore, it means Y will be equal to 128 degrees. That will be the value of Y. Now we've got the value of Y here. The value of Y is 128 degrees. Thank you. Still have to determine X. How can you determine X? We've got different approaches. We've got different ways you can solve X using different approaches. Let's carry on. Thank you. Let's determine the value of X. Some will say, look at X and 64. Remember, O is the center. OP is therefore the radius. MPT is the tangent. So we know the theorem that states a tangent to the circle is perpendicular to the radius at the point of contact. A tangent to the circle is perpendicular to the radius at the point of contact. What does that mean? It means X plus 64 degrees must give you 90. X plus 64 degrees equals 90. Tangent, because the tangent is always perpendicular to the radius. Tangent perpendicular to the radius. Then you just have to solve X. Therefore, X will be equal to 26 degrees. Because you've got to transpose 64 to the right, then you've got 90 minus 64, which will give you 26 degrees. That's how we solved that one. We applied theorems to calculate the sizes of angles. We applied theorems to calculate sizes of angles. So we are done with this one. Very much interesting. Very much interesting. So I'm going to take a break. I'm going to take a break and have a cup of water. But in the meantime, I'm going to leave you with an exercise to do. I'm going to leave you with an exercise to do. I think for you to complete the exercise, it will take you about 5 minutes. I'm going to give you 5 minutes to complete the following exercise. Thank you. Here is the exercise then. Here is the exercise. It reads, in the diagram below, 2 circles have a common tangent TAB. In the diagram below, 2 circles have a common tangent TAB. PT, here is TAB. PT, this PT is a tangent to the smaller circle. You can see you've got 2 circles there. This is a smaller circle and the bigger circle. So they've got this common tangent TAB. And also PT is a tangent to the smaller circle. PAQ, QRT, and AR are straight lines. Then let Q be equals to X. Here is Q is already marked with X. The first question states, name with reasons 3 other angles equal to X. You have to apply your theorems and name 3 other angles equal to X. And then lastly, you then have to prove that APTR is a cyclic quad. While I'm having a water, I'm going to give you 5 minutes to finish off that one. And then I will take you through the solution there. Thank you. Welcome back. I hope you had 5 interesting 5 minutes whereby you were busy trying to solve this problem. Let me take you through the problem there. It reads, in the diagram below, 2 circles have a common tangent. It means TAB is a tangent to both circles. Then once you've got a tangent, once you see the word tangent, then 3 theorems must come to your mind. Tangent perpendicular to radius, tan chord, and tangents drawn from the same point outside the circle are equal in length. Those are the 3 theorems associated with tangents. Tangents drawn from the same point outside the circle are equal in length. Tan chord and tangent perpendicular to radius. But if we read it further, there is no indication of the center here. So we forget about the tangent perpendicular to radius theorem because you do not have the center. The center is not indicated. PT is also a tangent to the smaller circle. See, PT is also a tangent to the smaller circle. So it means already PT will be equals to AP according to that theorem, which states tangents drawn from the same point outside the circle are equal in length. It means TA will then be equals to TP. It is important immediately to indicate all the given information on the diagram. You mark them equal. This is equals to that one. It's PT is equals to AT. Those are the 2 tangents drawn from the same point outside the circle. And when you apply, you remember we've got different types of triangles. Even before you answer the questions, for different types of triangles. And you remember one of the triangles is an isosceles triangle. Look at triangle PAT. Triangle PAT therefore becomes an isosceles. Therefore, this angle P1 will also be equal to angle A3. We are just analyzing. Thank you. And remember, if we've got a chord, then we can apply the tan chord theorem. Tan chord can be applied in different ways. P1 can be equal to N. A6 will be equal to R2. A2 will be equal to X, and so forth. We haven't even started solving the problems, but I'm just trying to indicate to you how to apply the tan chord theorem. We are just analyzing the information. So Q is equal to X. The first question states, name with reasons 3 other angles equal to X. We name with reasons 3 other angles equal to X. Thank you. Because TAB is a tangent to the bigger circle, so angle A2 will be equal to X according to tan chord theorem. Let me write it down. The first angle will then be angle A2 will then be equal to X. Where is A2? This here is A2. It means this angle is also X according to tan chord theorem. Tan chord theorem. A2 is equal to X. That is the first angle. The question states name with reasons 3 other angles equals to X. So we already have the first one, it's A2. The second one, the second angle equals to X. We have X here, we also have X here. If you look at A2 and A5, there is a relationship. Those are the vertically opposite angles. And vertically opposite angles are always equal. Therefore, it means angle A5. Angle A5 is equals to angle A2. And I remember A2 is also equals to X. Why do I say A5 is equals to A2? Because those are the vertically opposite angles. Those are the vertically opposite angles. So we go to A5. You mark it X as well. A5 is also equals to X. So the question says name with reasons 3 other angles. Look at A5. Look at P2. It means A5 will also be equals to P2 according to tan chord theorem. The third theorem will then be P2, angle P2 is also equals to A5. And remember, A5 is equals to X. So it means P2 is also equals to X. What is the reason for that statement? Why do I say A5 is equals to A2? The reason is the tan chord theorem. Tan chord theorem. So those are the 3 angles equal to X from that diagram. Thank you. Did you get them right? but it's very much interesting. Let's go to the next section, the second part of the question, which states, prove that APTR is a cyclic quad. Prove that APTR is a cyclic quad. We have three ways of proving a quad to be cyclic. There are three ways of proving a quad to be cyclic. Number one, if the exterior angle of a triangle is equal to the interior opposite, if the exterior angle of a quadrilateral is equal to the interior opposite angle, then the quadrilateral becomes cyclic. Secondly, if the opposite angles of a quadrilateral are supplementary, then it means that quadrilateral is also cyclic. So, thirdly, if the angles subtended by the same side of a quadrilateral are equal, if those angles subtended by the same side are equal at the vertex, therefore it means that quadrilateral is also cyclic. Those are the three ways of proving a quad to be cyclic. So you need to think hard and analyze the problem and see which way will be more appropriate this time. And every time the question is prove, when you are required to prove, I always say ask your question when. When whatever it is that you are required to prove will be true. Ask yourself a question when. For instance, if I have to, when prove that APTR is a cyclic quad, ask yourself a question when. When will APTR be a cyclic quad? You've got quite a number of possibilities. It can be if R2 equals to P1, exterior angle, interior opposite angles. Or if you can say, you see P3 plus P2, if they can be equal to R1, that is a possibility. Or if R1 plus P1 is equal to 180 degrees. Those are the possibilities. So if you look down, you analyze and see what you have, then you work on what you have mostly. Look at the information that you have and then look at the part that is more relevant to the given information. So when answering this question, when will APTR be a cyclic quad? When will APTR be a cyclic quad? If we can prove that angle R2 is equal to angle P1. Now we have a direction. If R2 can be equal to P1, then we can prove that. Let's work towards that. Thank you. Proof. Then you ask yourself a question when, so that you should have a direction. You must know I'm working towards achieving this objective, towards reaching this destination. Prove that APTR is a cyclic quad. The question is, when will APTR be a cyclic quad? And the answer is if R2 can be equal to P1. Now we start looking for angles that are equal to P1 and those that are equal to R2. Let's start. Already P1 is equal to A3 from the information that TP and TA are tangents. So we start. A1, P1 is equal to A3. That's the statement. We are now at 4.2 now. 4.2. P1 is equal to A3. Think of the reason. See, because PT is equal to AT. That's the reason. PT is equal to AT. And that is according to a theorem that states tangents drawn from the same point. Tangents drawn from same point outside the circle. Those are the tangents drawn from the same point outside the circle. In full, the theorem states tangents drawn from the same point outside the circle are equal in length. That is how we say PT is equal to AT. PT is equal to AT. Because those are the tangents drawn from the same point outside the circle. Look at A3 and A6. What is the relationship? Vertically opposite angles. Therefore, A3 is also equal to A6. Those are the vertically opposite angles. Vertically opposite angles. Look at A3, look at A6. I'll mark them equal. All the angles that I'm marking, they will be equal. Remember I said P1, I marked it like this, is equals to A3. Now A3 is equals to A6. Those are the vertically opposite angles. I've marked them the same. All those angles are equal. It means P1 is equals to angle A3 is equals to angle A6. Now check the relation between angle A6 and R2. Angle A6 and R2. Tan chord. Thank you. Therefore it means A6. Angle A6 is also equals to angle R2. That is according to tan chord theorem. Tan chord theorem. All the angles that I've marked are now equal. It means R2 also I must mark it exactly the same. Mark it like that. All those angles are equal. P1 is equals to A3 and A3 is equals to A6 and A6 is also equals to R2. I have been providing reasons all along. So all those angles are equal. What does that mean? Therefore means we conclude. We therefore means angle R2 is equals to P1. Therefore angle R2. It's a deduction. The moment you say therefore, you deduce from the above statements. From the above statements, we can then draw a conclusion that states angle R2 is equals to P1. Check at R2. Check at P1. With respect to APTR, R2 becomes an exterior angle and P1 becomes the interior opposite angle. Then you conclude that. Then we can conclude that APTR, therefore APTR is a cyclic quad. It's a cyclic quad. Why do you say it's a cyclic quad? Now you provide a reason. Why? Because the exterior angle is equal to the interior opposite angle. Because the exterior angle is equal to interior opposite angle. And once the exterior angle of a quadrilateral is equal to the interior opposite angle, then we know that that quadrilateral is cyclic. Interesting. Thank you. Every time, if I have to take you through the problem again, 4.2, prove that APTR is a cyclic quad. Ask yourself a question, when? Once you can answer that question, when, it gives you a direction. Then you know, I am working in this particular direction. This is the objective that I want to achieve. Now, in this case, we wanted to prove that R2 is close to P1 because we knew that if R2 and P1 can be equal, then APTR will then be a cyclic quad because the exterior angle will then be equal to the interior opposite angle. Just have to do lots and lots of exercise. Remember, as a grade 12 learner, you need to practice mathematics more often. And through practice, it will then become perfect. That's why I'm just taking you through this practice session. We are now practicing Euclidean geometry because we know very well that this coming test on Monday will also contain Euclidean geometry. Next one. Next one. Should we do it together or should I allow you to do it first? Let's do it together. I'll give you a chance for the next one to tackle it first. Okay? Let's analyze. Remember the key. When you analyze, where possible, indicate the given information on the diagram. Let me take you through it. In the figure, here is the figure. TP and TS are tangents. Check. TP, TS are tangents. Already from there, you must be able to recall it from the problem that we did earlier. Tangents drawn from the same point outside the circle are equal in length. Once it is given that TP is equal to TS is the direct information, indirectly, they want you to know that this side is equal to this one. TP is equal to TS. Why? Remember, tangents drawn from the same point outside the circle are equal in length. That's why we say TP is equal to TS. And then it will then mean triangle PST becomes an isosceles triangle, meaning that P1 will then also be equal to S1. You already mark with an X. P1 is also equal to S1 is an X, because P1 is given as X. It means S1 will also be equal to X. We're just analyzing the rider. It's a geometric rider, this one. We are just analyzing it. R is a point on the circumference of the circle. Here is R. It's a point on the circumference of the circle. Q is a point on PR. Fine, thank you. And Q1 is equal to P1. Let's mark them. Q1. This is Q1, which is equal to P1. So P1 is given in terms of X. It means Q1 is also equal to X. Those are the equal angles. It's very much important, given. And every given information, we need to use information, because that information is given to enable you to solve the problems. So it's given P1 is equal to Q1. So if P1 is X, it means Q1 is also X. We are just analyzing. We haven't yet even started with the solution of the problem. We are just analyzing. Let P1 be equals to X, okay? P1 already marked X there. So already, even before you try and attempt to answer the questions, you can see that S1, Q1, P1, those are the equal angles. From analyzing the diagram, the geometric rider, you just analyze the geometric rider. Now, let's go to the questions. The first question states, prove that TQ is parallel to SR. Prove that TQ is parallel to SR. Ask yourself the question, when? When will TQ be parallel to SR? Once we've got two lines that are parallel to each other, we've got a number of theorems that we can apply. If alternating angles can be equal, which alternating angles are those? If Q2 can be equal to S3. If the corresponding angles can be equal, which angles are corresponding? You can see if Q1 is equal to R. Those are the corresponding angles. Because we want to prove that, the question says, prove that TQ, here is TQ, TQ is parallel to SR. We want to prove that. So for us to prove that, it's either the corresponding angles will be equal, or the alternate angles will be equal, or the co-interior angles will be supplementary. Angle R plus Q3 plus Q2 will give you 180 degrees. So that's why I say every time you are asked to prove, ask yourself a question, when? And then look at the given information. Look at the given information. And then what do? You first start with the information, the given information. Where is it applicable? How can we use it to prove, like in this case, how can we use X here, this X here, even that one, to prove that TQ is parallel to SR? I always say, you ask yourself a question, when? Others will say if Q2 can be equal to S3. But look at Q2 and S3. Do you have information on them? At the moment, we don't. But X, already we know this one. So if Q1 can be equals to angle R, ask yourself a question, when? When will TQ be parallel to SR? If Q1 is equals to R. Why do I choose that one? Because already I've got information about this. And from, if PT is a tangent, you already think of the tan chord. Let's work it out then. I think some of you already see the solution. Because ultimately, what is our destination? We want to prove that Q1 is equal to R. Because if Q1 can be equal to R, then it means TQ will be parallel to SR. Let's go. Number one, P1 is 5.1. P1 is equals to R. P1 is equals to R. Reason? Tan chord. P1 is equals to R. Tan chord. Again, remember, P1 is equals to Q1. This is the given information. from the given, remember the statement, Q1 is equals to P1. It's given information. This one is given. It's a given information, this one. From the two statements, what conclusion can you draw? The first thing, P1 is equals to R, P1 is equals to Q1. From the two statements, we can therefore draw a conclusion that angle R is equals to Q1. Therefore, angle R is equals to Q1. Look at Q1 and R. What is the relationship between the two angles? Here, the reason for us to say angle R is equals to Q1 is because they are both equals to angle P1. But then we say the question is now, what is the relationship between Q1 and R? You can see they lie on top of these two lines. Therefore, those are the corresponding angles. So it means in this case the corresponding angles are equal. And remember, corresponding angles will only be equal if and only if they lie on parallel lines. That's why now we therefore draw a conclusion that it therefore means TQ is parallel to SR. Why do I say this line TQ is parallel to SR? The reason is that because the corresponding angles are equal. Because corresponding angles are equal. That is the reason. First part of the problem done. We wanted to prove that TQ is parallel to SR. Now, because we have proven that, we mark that on the diagram. Mark them. This one, this line is now parallel to this one. We have proven that. Let's go to this second part of the question. The second part of the question states, prove that QPTS is a cyclic chord. QPTS is a cyclic chord. Let me repeat my words again. Earlier on I said there are three ways of proving a chord to be cyclic. If the exterior angle of a quadrilateral is equal to the interior opposite angle, then the chord will be cyclic. If you look at this one, if Q3 can be equal to angle T, if Q3 can be equal to the whole of angle T, then it means QPTS will be a cyclic chord. Secondly, if the opposite angles of a quadrilateral are supplementary, then the chord can be cyclic. Look, angle T plus Q1 and Q2. Those are the opposite angles. If they give you 180, you can conclude by saying a QPTR is a cyclic chord. Lastly, if the angles subtended by the same side are equal, check. If you can prove that angle P2 is equal to T2, but P2 and T2 you don't have much information on them. Or alternatively, if you can prove that P1 is equal to Q2, check P1 and Q2. Can we prove that? At least we have talked about Q1. Alternatively, if you can prove that Q1 is equal to S1, now that one already, we have already worked it out. If Q1 can be equal to S1, because Q1 is subtended by PT, S1 is also subtended by side PT. If angles subtended by the same side of a quadrilateral are equal, then that quadrilateral is then cyclic. So in this case, see, if you can prove that angle Q1 is equal to angle S1, because Q1 and S1 are subtended by PT. And already if we weigh options, now you can see already we can work that one out. Now let's work it. Remember the information that is indicated here is when we are just analyzing the problem. Let's go to 5.2. 5.2. We want to prove that Q1 to be equals to S1. That is our destination. Ask yourself a question. When will QPTS be a cyclic chord? When will QPTS be a cyclic chord? The answer is if S1 can be equals to Q1. Now we're going to work it out properly to prove that S1 is equals to Q1. Remember, already I said P1 is equals to S1. It's very much important to provide appropriate reasons. This is a Euclidean geometry. In Euclidean geometry, you need to provide a statement, a reason for your statement. Why do we say P1 is equals to S1? Because TS is equals to TP. P. Why do I say TS is equals to TP? Because those are the tangents. Tangents drawn from the same point. In full, the theorem states tangents drawn from the same point outside the circle are equal in length. That's why we say T is the common point. That's why we say TP is equals to TS. So we've got P1 is equals to S1. But remember, P1 is equals to Q1. Remember that. P1 is equals to Q1. Why? Because check the given information. It was given. Q1 is equals to P1 from the given statement. Therefore, this is given. From the two statements, P1 is equals to S1, P1 is equals to Q1, we draw a conclusion. Therefore, it means S1 will then be equals to Q1. They are both equals to S1. Both equals to angle S1. Both equals to angle S1. Now, if S1 is equals to Q1, remember that was the destination target. This was our target. This was our destination. This is where we want to come in order to prove that QPT is a cyclic quad. That's where you want to come. Therefore, we have arrived at that stage to say S1 is equals to Q1. Now you draw a conclusion. Therefore, QPTS is a cyclic quad. Why do we say QPT is a cyclic quad? Because the angles, because PT, check side, PT subtends equal angles. Thank you. That's how we prove that QPTS is a cyclic quad. The last part, I think we have done that. Still have to prove TQ. We need to prove that TQ bisects SQP. The last part, TQ bisects SQP. We need to prove that TQ bisects SQP. We need to simplify that one. What do we mean if we say TQ bisects SQP? Check TQ. Here is TQ, here is angle SQP, this angle. If we want to simplify this one further, it means all we have to do is to prove that angle Q1 is equals to angle Q2. If we want to simplify that one, TQ, here is TQ, SQP, here is SQP, angle SQP. So if TQ bisects angle SQP, it means Q1 will then be equals to angle Q2. That is what we want to prove now. Let's start. We want to prove that angle Q1 is equals to angle Q2. Remember 5.2. What did you do in 5.2? In 5.2 here, we have proven that QPTS is a cyclic quad. We have proven that QPTS is a cyclic quad. Because we have proven that it's a cyclic quad, we can apply the theorems of a cyclic quad there. You remember the theorems associated with cyclic quad. Exterior angles also interior opposite angle. Opposite angles are supplementary, and angles supplementary the same chord or angles supplementary the same arc are equal. Now, let's apply. Let's prove. It's 5.3. 5.3. We start. We want to prove that Q1 is equals to Q2. Look for angles that are equals to Q1. P1 is equals to Q1. The given information. P1 is equals to Q1. This was given. This was given. Remember here. P1 is equals to Q1. This was given. Then look at P1 is equals to Q2. P1 is equals to angle Q2. Think of the reason. Why do we say P1 is equals to Q2? Why do we say angle P1 is equals to angle Q2? Let me give it, because those are the angles subtended by same chord. This chord in this case will then be TS. TS. And P1 is equal to Q2, angle subtended by the same chord. That chord will then be TS. Remember, in 5.2, we have proven that QPTS is a cyclic quad. So remember, the sides of a cyclic quad, they form chords of a circle. Sides of a cyclic quad are basically the chords of a circle. That's why I'm saying TS is then a chord. So TS subtends angle P1, and again TS subtends Q2. Therefore, P1 is equal to Q2. Those are the angles subtended by the same chord. Thank you. From the two statements, we draw a conclusion. Therefore, Q1 is equals to Q2. So if angle Q1 is equal to angle Q2, what does that mean? It therefore supports the statement that TQ bisects angle SQP, angle SQP. The word bisect means to cut into two equal parts. That's why we say Q1 is equal to Q2. I hope you are enjoying yourself at the moment. We are just busy with the application of the theorems. We are applying the theorems. Mathematics, in maths, we believe that practice makes perfect. So it's through practice that we become better and better in mathematics. So I'm going to give you another exercise again while I'm having a cup of water. Give you one exercise, apply your theorems, and see how far do you go. The simple one, find X and Y. Check at the given information. BE is parallel to AF. EF is parallel to BA. That is what is given. And DE is 20, EC is 30, FC is Y, DB is X. For 5 minutes, find me the value of X and Y. While I'm having a cup of water again, please find the value of X and Y. Good luck. Welcome. Let's carry on with the solution of this one. I think this is more of the proportionality theorem. The proportionality theorem is the theorem that states a line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. A line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. That is the proportionality theorem. Let's check. Why am I talking about that? Because you look at this bigger triangle ADC. You've got DE, which is parallel to AC. So this DE, because it's parallel to AC, it divides this side, DC and D and AD, in the same proportion. It means DE over AC is equals to DB over BA. Again, you look at that bigger triangle, triangle ACD. Check. EF is parallel to DA. A line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. That means F and E divides AC and DC respectively so as to divide them in the same proportion. Meaning that Y over FA is the same as 30 over 20. Thank you. Now let's start. Look at this quadrilateral. ABEF. ABEF. Pair of opposites are parallel. Therefore, it's called a parallelogram. You know a parallelogram? Pair of opposites are equal. Now we start. Means AF is equals to 15. Now you mark 15 here. It's also equals to 15. Why? Those are the opposite sides of a parallelogram. Opposite sides of a parallelogram, of a palm. In the very same reasoning, you look at EF and AB. They must also be equal. It means AB is also equals to 20 units. Opposite sides of a palm. Opposite sides of a palm. So you mark 20 here. You mark 20 there. Then we start solving. Let's start by solving x. X over 20. Check. X over 20 is equals to 20 over 30. We have this line, BE, parallel to AC. A line parallel to a side of a triangle divides the other two sides so as to cut them in the same proportion. Therefore, it means x over 20 is equals to 20 over 30. Now you just have to solve for x. So your geometry, we are based with Euclidean geometry, provide a reason. Why do I say x over 20 is the same as 20 over 30? A line parallel to a side of a triangle. A line parallel to a side of a triangle. We know that a line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. So let's solve for x. For us to be left with x, we multiply by 20 both sides. If you multiply by 20 here, you are left with x. You multiply by 20 here, then you got 20 over 30 multiplied by 20. Then we can determine the answer there, which is basically same as x will then be equals to, if you multiply, 0 will cancel 0, then it will have 40 over 3. 40 over 3. 40 over 3 is the value of x. Let me take you through it first. We said BEFA is a parallelogram. Let me show you the diagram. Let me show you the diagram. BEFA is a parallelogram because it is given that the pair of opposite sides are parallel. So it becomes a parallelogram. And one property of a parallelogram is that opposite angles are equal. That's why we say AF is 15 units, AB is also 15 units. Then we go to proportionality theorem. If we go to proportionality theorem, we set x over 20, 20 over 30. X over 20 is equal to 20 over 30, a line parallel to a side of a triangle. Then you solve x, ultimately x is equal to 40 over 3. So we've got the value of x here. Let's write it down. This x is basically equals to 40 over 3. Now let's determine the value of y. Let's calculate y. Let's calculate y. Let's calculate y. In the same way, check. Y over 15 is equals to 30 over 20. Y over 15, 30 over 20. It's a geometry. It's a statement. Let's provide a reason. The reason is a line parallel to a side of a triangle. We know that a line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion or in the same ratio. Now to solve y, multiply by 15 both sides. You multiply by 15 here, you are left with y. You multiply by 15, it will be 30 over 12, multiply by 15. Then you work it out, then that will be the value of y. If you simplify it further, you can even say 3 into 12 goes 4 times. 3 into goes 5 times. Then 2 into 4 twice. 2 into 30 is 15. Then you've got 15 multiplied by 5, which will give you 45 over 2. Basically, the value of y will then be 45 over 2. You can work it out. This is more of an application relating to the theorem in grade 12, which we call the proportionality theorem, which states a line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. Thank you. Thank you. Do you want, let me give you another example similar to this one, because it also requires the application of proportionality theorem. Let me give you another exercise. Here is the other exercise on proportionality. Here is the other exercise on proportionality. Thank you. Let's go through it together. Let's go through it together. In the diagram, PQRS is a parallelogram. Let's work it out. PQRS is a parallelogram. If it is a parallelogram, opposite angles, pair of opposite sides are equal and parallel. Parallelogram, pair of opposite sides equal and parallel. Thank you. What does that mean? It means, if we have to simplify it further, PQ squares to ST. Those are the sides of a parallelogram, opposite sides of a palm. QR squares to PS, also the opposite sides of a palm. Side RS is proportional to W. WQ intersect PS in X. M is a point on XQ such that MX, what is MX? MX is equals to XW. It's marked on the diagram. Marked nicely. Given that MT is parallel to X, what is MT? Let's look at MT. MT is parallel to XS. Even if it's given, MT is parallel to XS. Given that MT is parallel to X, PQ is 12. What is PQ? This PQ is 12 centimeters, indicated on the diagram. WS, what is WS? This WS is 4 centimeters. Determine, number A, determine the length of TR. You've got to determine the length of TR. Here is TR. We want the length of this TR based on that given information. I think this is simple arithmetic. Simple arithmetic in the sense, look at this diagram from this point. You've got WS over ST is equal to WX over XM. And it is given that XW is equal to MX. Then you think of the midpoint theorem from grade 10. The midpoint theorem from grade 10. The midpoint theorem from grade 10. If this X is a midpoint, and S must also be if X is a midpoint and XS parallel to MT, then what does that mean? It means S is also the midpoint of the other side. What does that mean? It therefore means this ST will also be equals to 4. Midpoint theorem from grade 10. If X is the midpoint of MW and XS is parallel to MT, therefore WS is also equals to ST from grade 10. Now I want to answer the question now. If we answer the question, we'll then say is given WX over XM is equals to WS over ST. A line parallel to a set of a triangle divides the other two sides proportionally. But the fact that XS is parallel to MT, it leads you to draw a certain conclusion that WS is equals to ST. Therefore, if WS is given as 4, ST will also be equals to, ST will then be equals to 4 units. This is from midpoint theorem. Midpoint theorem from grade 10. Now we've got ST as 4. Remember, it is given that PQ is 12 centimeters. So it means SR is also 12 centimeters. You say SR is equals to 12 centimeters. Why? Because these are the opposite sides of a parallelogram. SR is 12 centimeters. Those are the opposite sides of a parallelogram. So if SR is 12 centimeters, check. SR, the whole of SR is 12. ST alone is 4. Therefore TR will then be equals to a simple arithmetic 8 centimeters. Now we've got TR is equals to 8 centimeters. So 8 and 4 will give you 12. SR will be equals to PQ. Those are the opposite sides of a parallelogram. The first part of the question answered. Determine the length of TR. Now we have determined the length of TR. TR is equals to 8. And basically what helped us there was the midpoint theorem from grade 10. We still need to apply those theorems from grade 10. Thank you. The B part of the question states, the B part, determine XM over XQ, XM over XQ. This is what we want to determine. Determine this. Determine XM over XQ. Let's go. XM over XQ. I start first by saying XM is equals to XW. XM is equals to XW. It's given. It was given. MX XW. This was from the given. It's given. From the diagram earlier on, remember? MX is equals to XW is given. MX is equals to XW is given. Therefore, let's work out the ratio here. Let's work out the ratio. Let's work out the ratio of XW. Let me say WX over XQ. WX over XQ. This will be equals to WX, you take WS over SR. You remember the theorem. A line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. WX over XQ is equal to WS over SR. Let's check the ratio. What is the ratio? The ratio here, it means WX over XQ will then be equals to WS which is 4 over SR which is 12. Can simplify the ratio further to say the ratio here is 1 over 3. Can simplify this as 1 over 3. So WX, remember WX is equals to XM. The question is determine the value of XM over XQ. So WX, here is WX is equals to XM. Now instead of WX here, I substitute it by XM. Therefore it means XM over XQ then becomes to 1 over 3. This is one other problem where we applied more or less the theorem that states a line parallel to a side of a triangle divides the other two sides so as to divide them in the same proportion. Thank you. Let's carry on with our exercises. We need to do lots and lots of exercises. We say practice makes perfect. Through practice, it's only then that you become perfect. It's only then that you become familiar to say this theorem is applied this way. Through practice. Mathematics is one subject that requires a learner to practice. Thank you. Let's do number 7. Let's do this one. I guess some of you are already getting tired now. Let's do this one. Number 7. What is given? Let's go through the problem together. O is the center. O is the center. Thank you. BP is equals to OB. BP, we mark it on the diagram, mark it. BP is equals to OB is equals to OA. OA and OB, those are the radii, because O is the center. Therefore, they are also equals to BP. PTR is a tangent. PTR, this line is a tangent. Then you think of a tan-cot theorem. Then you think of the tan-cot theorem. EP perpendicular to AP. Here is this EP perpendicular to AP. Here is 90 degrees here. Thank you. Let's go to the first question. Prove that TEPB is a cyclic quad. TEPB. TEPB is a cyclic quad. To simplify the problem for us, let's say we've got angle E1 here, angle E2, T1, T2, T3, B1, B2, B3. Thank you. We try and simplify the problem. Prove, the question states, prove that TEPB is a cyclic quad. TEPB is a cyclic quad. When? When will TEPB is a cyclic quad? There are three ways. I think those theorems must just be, they must come automatically to you. Once the question says prove that TEPB is a cyclic quad, then you think of the three possibilities. If the exterior angle equals to the interior opposite angle, if the opposite angles are supplementary, if the angles are on the same side are equal. Check this one. And you relate that to the given information. See, look at the given information. What is given? They are given that this angle is 90 degrees. And O is the center. So it means AB is a diameter. If AB is a diameter, 7.1. If AB is a diameter, it means angle T3. Angle T3 is equals to 90 degrees. Angle T3 is equals to 90 degrees. That is an angle subtended by diameter. Because it is given that O is the center, and we know the straight line that passes through the center is a diameter. So AB is a diameter. So T3 will be equal to 90 degrees. Angle P is also equal to 90 degrees. Why do we say angle P is equal to 90 degrees? Because it is given that EP is perpendicular to AP. This one is given. Given that EP is perpendicular to AP. That's why we say this angle P is equal to 90 degrees. Therefore, we draw a conclusion. It means angle T3 is equals to angle T3 is equals to angle P. What is the reason? They are both equals to 90 degrees. Both equals to 90 degrees. So if this angle is 90 here, let's mark it. It's 90. You look at P. What is the relationship? T3 and angle P. How do they relate? You can see that with respect to TEPB, T3 becomes an exterior angle. Angle P becomes the interior opposite angle. Therefore, we conclude by saying, remember the question, TEPB. TEPB. This is the conclusion. TEPB is a cyclic quad. Is a cyclic quad. Why do we say TEPB is a cyclic quad? Because the exterior angle is equals to the interior opposite angle. That's the first part. Now that we have proven that TEPB is a cyclic quad, it means we can apply the properties of a cyclic quad on that. Which other properties do exist? Like T2 is equals to E1, it's correct. Like B1 is equals to T1, that will be correct. Angles are the same chord. Those are the theorems that we can apply because we have already proven that TEPB is a cyclic quad. That was the first part of the question. Let's go to the second part. The second part of the question, 7.2. Prove that triangle ATB. Let's go to triangle ATB. ATB, this triangle. ATB, this triangle. It's grabbing the circle. Triangle ATB is similar to triangle, let's check, APE. APE, the bigger triangle. Triangle APE and triangle ATB. By merely, if you start, remember, to prove similarity, to prove that two triangles are similar, you only need to prove two pairs of angles to be equal. You only need to prove two pairs of angles to be equal because the remaining pair definitely be equal. Remember, angles of a triangle add up to 180 degrees. Angles of a triangle, they are supplementary. They add up to 180 degrees. So if the first two pairs are equal, automatically the remaining pair will also be equal. So that's why I'm saying if the question states, if you are required to prove the similarity between any two angles, just to prove the first two pair of angles to be equal, because the remaining pair will automatically be equal. Thank you. Let's look at triangle ATB and ATP. There's something common. Angle A belongs to the two triangles. Angle A belongs to the two triangles. We say angle A, we are answering 7.2 now. 7.2. Angle A is equals to angle A. It's common. It's common. ATB, AEP. So A is in both triangles. Angle T3 is equals to, this angle T3 is equals to P. We have proved that in number 1, both equals to 90. Or you can say proved in 7.1. Remember 7.1, we proved that T3 is equals to P. That's why we concluded that T3, that's why we concluded that TEPB is a cyclic quad. Or you can say T3 is equals to P, exterior angle of a cyclic quad is equals to the interior opposite angle, because we have proven that TEPB is a cyclic quad. So T3 is equals to P. So in triangle ATB, we have talked of angle A, we have talked angle T3, we are left with angle B3. We haven't yet talked about angle B3. And in triangle APE, we have talked of angle A, we have talked of angle P, we still have to talk with the whole of angle E. Let me say angle E, it means it's both angle E1 and E2. Those will be the remaining angles. If you apply the theorem that says angles of a triangle are supplementary, therefore those are the remaining angles, therefore they have to be equal. Now, order is very much important here. It's very much important. Therefore, triangle ATB is similar to triangle, check, remember, angle A is common. We started with A here, must also start with angle A. AT, we went to T, remember T3 we said is equals to P, then you go to P. B3 is equals to that E, then you go to E. And you must always provide a reason. Triangle ATB is similar to triangle APE. The reason, provide a reason. Angle, angle, angle. Because we've talked of the first pair of angles here, the second pair of angles, and the third pair. So that should be the reason. I think 7.2, we've done it well. Let's look at 7.3. 7.3. 7.3, it states, prove that TP is equals to PE. Thank you. Prove that TP is equals to PE. When will TP be equals to PE? Check TP. Check PE. When will they be equal? If T1 can be equals to angle E. If T1 can be equals to angle E, then it means TP will be equals to PE. Check. Thank you. 7.3. 7.3. Should look at the whole diagram. 7.3. Prove that TP is equals to PE. The answer is, the question is, when will TP be equals to PE? The answer is if angle T1 can be equals to angle E. That's the way to go. Thank you. We've got our target at the moment. We need to prove that angle T1. Look at where T1 is. TP, TP, PE. T1 must be equals to E, the whole of angle E. And remember, we have proven that TEPB is a cyclic quad. TEPB is a cyclic quad. Very much interesting. So every time you ask a question, prove. The answer is when. I'll just have a cup of water for 2 minutes while you work it out, because I can see my voice is almost running out now. It's a bit tired. For the next 2 minutes, do number 7.3 for me, please. Let's carry on with solution. Thank you. I gave you 3 minutes to solve it. I hope you've managed. Remember what I indicated to you. I indicated to you that in 7.1 we have proven that TEPB is a cyclic quad. So, and remember, angle T3 is equal to 90 degrees. That is an angle subtended by diameter. That is an angle subtended by diameter. Therefore, if T3 is equal to 90 degrees, it means we are now in 7.3. It means angle T1 plus angle T2 also gives you 90 degrees. Those are the angles on a straight line. Remember, T3 is 90. Therefore, T1 plus T2 is also 90. Because you add them all together, they'll give you 180 degrees angles on a straight line. Therefore, it means T1, if you make T1 the subject of the formula, T1 will be equals to 90 degrees minus angle T2. 90 degrees minus T2. Check T2. Check T2. 90 degrees minus T1 is equal to 90 degrees minus T2. And remember, B1 and T1, because we have proven that TEPB is a cyclic quad, T1 is also equals to B1. T1, maybe I should also indicate that T1 is also equals to B1. Remember, check. TEPB is a cyclic quad. What does that mean? It means T2 is equals to E1. T2 is equals to E1. Remember, T2 is equals to angle E1. Why do I say T2 is equals to E1? We need to provide a reason. T2 is equals to E1. Those are the angles subtended. Those are the angles subtended by same chord. Where is that? Let me check. T2, E1. Angle T2 is equals to E1. Subtended by chord BP. Subtended by chord BP. Check in this triangle. In this triangle, TEB. This angle is 90 degrees. This angle is equals to 90 degrees. Therefore, it means B1 plus E1 also gives you 90 degrees. E1 plus B1. They will also give you 90 degrees. Why do I say E1 plus B1 is 90? Because E1 plus B1 plus P is 180 degrees. Those are the angles of a triangle. So if you transpose 90 to the other side, it means you'll be left with B1 plus E1 being equals to 90. From that theorem that states angles of a triangle are supplemented. Then check. T1. We said T1 is equals to 90 degrees minus T2. T1 is equals to 90 degrees minus T2. Now I'm saying E1 plus B1 is equals to 90 degrees. Let me make E1 the subject of the formula. E1 is also equals to 90 degrees minus B1. 90 degrees minus B1. Check the two statements. T1, 90 degrees minus T2. Remember, T2 is equals to E1. T2 is equals to E1. Therefore, it will therefore mean T1 is equals to the whole of angle E. Then you conclude that angle T1 is equals to the whole of angle E. So if T1, if this angle is equals to the whole of this angle, therefore you draw a conclusion that AT, what is it? PT will then be equals to PE. Therefore PT will be equals to PE. E. And I think that gives us the solution to number 7.3. Check 7.4 there. Check 7.4. I think this will probably be the last problem. 7.4. In 7.4, the question is, prove that ATB, triangle ATB, this triangle, is similar to triangle EPB. Check triangle ATB, check triangle EPB. Then we are now at 7.4. What is common about the two triangles? Triangle ATB and triangle EPB. Already you've got angle T3, you've got that one, it's 90 degrees. It's 90 degrees. And check B1, this angle B1 is equals to T1. T2 here, according to tan chord theorem, T2 is equals to angle A. Check angle T2 is equals to angle A, according to tan chord theorem. Check the triangles that you are working with. Triangle ATB. This triangle ATB and triangle EPB. And triangle EPB. We want to prove that the two triangles, we want to prove the two triangles to be similar. And for two triangles to be similar, I said, like I indicated earlier, you only need to prove two pairs of angles to be equal. Once you've got the two pairs equal, then the remaining pair will automatically be equal. So already you've got angle T3 and angle P, which is 90, which are both equal to 90. So we look for one more pair of angles that are equal. And remember, B3 from the earlier workouts, B3 is equals to the whole of E. Thank you. Let's work it out. Check angle T2. Angle T2 is equals to angle A. See? T2 is equals to angle A. Give me a reason for that statement. Angle T2 is equals to angle A. Why do I say angle T2 is equals to angle A? According to tan chord theorem. Tan chord theorem. Tan chord theorem. T2 is equals to angle A. But look at angle T2 again. T2 is equals to A1. The very same angle T2 is equals to A1. Why? Remember, in number 1, we have proven that TEPB is a cyclic chord. So if TEPB is a cyclic chord, it means T2 and E1, those are the angles subtended by the same chord. Angles subtended by chord BP. Angles subtended by the same chord, and that chord is BP. That's why we say T1 is equals to T2. Thank you. Now we start. Let's work out in the two triangles. Let's focus in triangle ATB and triangle EPB. Number 1. This is the information that we have just proven. T2 here. T2 is equals to A. T2 is equals to A1. Look, T2 is common. T2 is equals to A1, T2 is equals to A. So in the two triangles, it therefore means in triangle ATB, angle A is equals to angle E1. Both equals to T2. Angle A is equals to angle E1. Both equals to angle T2. We look at triangle ATB. Triangle ATB. We said T2 is equals to A. We also said T2 is equals to E1. Therefore, it means E1 is equals to angle A. Angle A is equals to E1. Both equals to angle T2. Thank you. That's the first pair. The second pair, remember, you said angle T3 is equals to angle P, and they are both equals to 90. Both equals to 90 degrees. T3 is equals to P, both equals to 90 degrees. Then you look in triangle ATB. The remaining angle is B3. In triangle ATB, we have talked of angle A, we have talked of angle T3, we haven't yet talked of angle B3. Therefore, the remaining angle will then be angle B3 will then be equals to, then you look in triangle EPB. In triangle EPB, we have talked of angle P, we have talked of angle E1. Then the remaining angle will then be angle B1. Then you can conclude. Triangle B3 equals to B1. Therefore, triangle ATB will then be similar to triangle. Check ATB will be similar to EPB. EPB. Order is very much important. A is equals to A, T is equals to P, B is equals to B. Even the order here, the order in which you take those letters must be the same. Why do we say they are similar? Angle, angle, angle. I think we have proven that part. That was 7.4. Prove that ATB is similar to APB. We have proven that ATB is similar to EPB. The last part of the work problem. Here we are. 7.5. We have already proven that ATB is similar to angle EPB. Why do we say the two triangles are similar? We've talked of T3, equals to 90. We've talked of angle A, equals to E1. We've talked of angle B3, equals to angle B1. So they are equiangular. 7.5. Prove that twice BP squared is equals to BE multiplied by TB. It is always very much important to know the given information. Remember earlier on we were given that BP is equals to OB, BP is equals to OB is equals to OA. Those were the radii. Thank you. Now we want to prove that twice BP squared is equals to BE multiplied by TB. Why do we have to take the sides in order? Because it makes the proportion easy. Let's check. It means if you can check it AB, AB equals to AO plus OB. If you take AB over, then you check on the TB. Order is very much important when writing that the two triangles are similar. Because if you take AB over TB, that will be the same as, instead of AB here, you can take EB, which is the same as BE over, we set TB here, then here will be PB or BP. BP. And then you cross multiply. And then you cross multiply. Let's cross multiply. If you cross multiply here, you've got AB multiplied by BP, which will give you multiply here TB by BE. Then if you multiply, you'll have BE multiplied by TB. Let's go to the diagram. Let's go back to the diagram. We are at this stage now. We've got BP, and remember the required to prove part, it has got BP squared. Everything, we already have BE multiplied by TB. We already have BE multiplied by TB. But we've got AB and BP here. So it means AB and BP, everything must be expressed in terms of BP. Now let's check. Go back to the diagram. Check AB. AB. AB basically is the same as AO plus OB. That's AB. AB is the same as AO plus OB. And then you multiply by BP. Remember, the product still BE multiplied by TB. Check AO. From the given information, it was given that BP is equals to OB is equals to OA. Then what do we do now? Instead of AO, we write BP. Plus, we've got OB. We still write BP multiplied by BP. The product will still be the same as BE multiplied by TB. BE multiplied by TB. Then you add the two, BP plus BP. Then if you multiply, you add BP to BP, you've got twice BP, going to multiply it by BP. The product is still BE multiplied by TB. Therefore, you multiply throughout, then you've got 2BP squared, which will then give you BE multiplied by TB. Then we have got the required to prove part. Twice BP squared equals to BE multiplied by TB. Thank you. I think I've come to the end of the session for today. And I still believe in mathematics, we need to practice. For you to master the theorem, you practice a lot. Practice makes perfect. We have done almost about 8 geometric diagrams for today, and it's a lot. We've been practicing and practicing. I believe if you can continue practicing, those theorems will be part of you. You'll just know when to apply a theorem. On that note, let me take the opportunity to wish you well in this coming test, and good luck even for June and September, and ultimately for the end of the year examination. I wish you all the best, but you need to work hard. You need to practice mathematics. Mathematics is a subject that needs to be practiced. Without practice, there is no way you can do well in mathematics. I wish you well and good luck. Thank you.